Hello students, today we are going to see paper 3 of electronics, which is a practical course. So now in this practical course there are two groups, group A and group B. So group A contain analog practicals and group B contain digital practicals. So in the group B there are study of logic gates and verification of truth table, binary to gray and gray to binary converter, half adder, full adder, XOR as a 4-bit parity generator and checker, decimal to BCD converter, multiplexer and demultiplexer, 3 by 4 matrix keyboard encoder, BCD to 7 segment display using IC 7447. So in group B we are going to see digital practical. So today we start our first digital practical, which is logic gate. So the first practical is to study and verify the truth table of logic gate. So the aim of this experiment is to study and verify the truth tables of different logic gates. So for these practicals, we need following apparatus. 5-volt power supply IC 7408, 7432, 7404, 7400, 7402 and 7486 and multimeter. Okay. So now we see our first logic gate, which is AND gate. For AND gate we use IC 7408. For AND gate we use IC 7408. So this IC has a 14 pin IC. That means this IC contain 14 pin, starting from pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, pin number 6 and pin number 7. Then pin number 8, 9, 10, 11, 12, 13 and 14. So 7408 is a 8 pin IC. Okay. So 7408 is a 14 pin IC. So out of this 14 pin, pin number 7 is a ground and pin number 14 is a VCC. VCC means supply voltage. So we provide the supply to this IC at pin number 14 and pin number 7 is ground. So this IC contain 4 AND gate. This IC contain 4 AND gate. AND gate 1, AND gate 2, AND gate 3 and AND gate 4. Okay, so now this is the first AND gate of this IC. So this AND gate contain 2 input and 1 output. So the input pins are 1 and 2. So pin number 1 and pin number 2 are the input of first AND gate and pin number 3 is the output of first AND gate. Now similarly 4, 5, 6. So 4 and pin number 4 and pin number 5 are the input to second AND gate and pin number 6 is the output of second AND gate. Similarly, pin number 9 and 10 are the input of third AND gate and pin number 8 is the output of third AND gate. Okay. So pin number 12 and 13 are the inputs of fourth AND gate and pin number 11 is the output of fourth AND gate. Okay. So this is the truth table of AND gate. So we know that AND gate perform a multiplication operation. So A and B, these are the condition. That means these are two inputs and Y is our output. So when both the inputs are low, that means when input A and input B both are 0, then we get the output 0. So at both the output at low condition, then our output is also low. So next the input A is 0 and input B is 1 and AND gate perform multiplication. So 0 into 1, 0 into 1, 0. So the output is 0. That means when one input is at low potential and second input is at higher potential, then we get the output at low potential. Okay. So the next input is 1, 0. 1, 0 means one input is at a high potential and another is at low potential. So similarly we get the output at low potential, which is 0 and 1, 1. So both the inputs are at a high potential, then we get the high output, which is 1. So 1 into 1, 1. So this is the AND gate and the IC for AND gate is 7408. Okay. Now the second gate is OR gate. Second gate is OR gate. So for OR gate we use IC 7432. For OR gate we use IC 7432. So 7432 is also a 14 pin IC. 7432 is also a 14 pin IC. So out of this 14 pin, pin number 7 is a ground and pin number 14 is plus VCC. So just like 7408, 7432 also contain 4 OR gate. Also contain 4 OR gate. OR gate 1, OR gate 2, OR gate 3 and OR gate 4. So pin number 1 and pin number 2 both are the input of first OR gate and 3 is the output of second OR gate, first OR gate. And 4 and 5, these are the input. Pin number 4 and pin number 5 are the input of second OR gate and pin number 6 is the output of second OR gate and pin number 7 is ground. Now pin number 9 and 10 both are input to third OR gate and pin number 8 is the output of third OR gate and pin number 13 and 12 are the inputs of fourth OR gate and pin number 11 is the output of fourth OR gate and pin number 14 is a VCC. So we provide the power supply to this IC at pin number 14. Okay, so we know that OR gate perform addition operation. OR gate perform addition operation. So here the truth table of OR gate is given. So A and B both are input and Y is the output. Okay, so the first condition is 0 0. That means both the input are 0. So 0 plus 0, the answer is 0. So here the output is 0. That means when both the input are at low potential, the output is also low. Now the next condition is 0 1. So when both the inputs, when one of the input is 0 and one of the input is 1, that means one input is low potential and another is high potential. So it gives output high. So 0 plus 1 1. So it gives the high output. Similarly 1 0. So 1 plus 0 1. Okay. Then 1 plus 1. So 1 plus 1 it gives the high output. So when both the input are at high potential it gives high output. So this is the OR gate. Okay. Now the third gate is NOT gate. Third gate is NOT gate and we use here 7404 IC for NOT gate. So for NOT gate we use IC 7404. Now this IC is also a 14 pin IC. This IC also contains 14 pins. So out of this 14 pins, pin number 7 is ground and pin number 14 is VCC. That means we provide a power supply to 7404 IC at pin number 14. Now this IC contains 6 NOT gate. This IC contains 6 NOT gate. NOT gate 1, NOT gate 2, NOT gate 3, NOT gate 4, NOT gate 5 and NOT gate 6. Okay. So now NOT gate has one input and NOT gate has one input and one output. So pin number 1 is the input of first NOT gate and pin number 2 is the input of first NOT gate. Similarly, pin number 3 is the input of second NOT gate. Pin number 4 is the output of second NOT gate. Pin number 5 is the input of first NOT gate and pin number 6 is the input of second NOT gate and pin number 7 is ground. So now pin number 9 is the input of fourth NOT gate and pin number 8 is the output of fourth NOT gate. Here also pin number 10 is the output and pin number 11 is the input. Here pin number 13 is input and pin number 12 is the output and pin number 14 is a VCC. So this bubble indicate that this is the output terminal. Okay. So 1, 3, 5. These are input terminal and 2, 4, 7. These are output terminals. Similarly here 9, 11 and 13. These are input terminal and 8, 10 and 12. These are the output terminal. Okay. So this is the truth table of NOT gate. So if the input NOT gate invert the input. The function of NOT gate is to invert the input. Okay. So suppose if the input is 0, then it generate the output 1. If input is 0, it generate output 1. It just invert the input. Similarly, when input is 1, the output is 0. So it generate the opposite output to input. So if input is at low, it produce high output, and if input is high, then it produce low output. Okay. Okay, the next gate is NAND gate. Next gate is NAND gate, and And here IC7400 is used for a NAND gate. Okay, so this IC also have a 14 pin. So out of this 14 pin, pin number 14 is VCC and pin number 7 is ground. So we provide the power supply to IC 7400 at a pin number 14. So this IC also contain 4 AND gate. This is 4 NAND gate. So this is NAND gate 1, NAND gate 2, NAND gate 3 and NAND gate 4. So pin number 1 and pin number 2 are the input of first NAND gate and pin number 3 is the output of first NAND gate. Similarly, pin number 4 and 5 are the input of second NAND gate and pin number 6 is the output of second AND gate. So pin number 9 and 12, the 9 and 10 are the inputs and pin number 8 are output. So pin number 12 and 13 are inputs and pin number 11 is the output and pin number 14 is the VCC. Okay, so NAND gate perform the reverse operation of AND gate. So basically NAND gate is the invert of AND gate. So this is the truth table of NAND gate. So A and B are input and Y is the output. Okay, so we know that AND gate perform opposite operation to AND gate. So basically it is the inverter of AND gate. Okay, so when both the inputs are 0 0, it generate high output. In AND gate we saw that when both the inputs are 0 0, it generate 0 output. So in NAND gate the condition is opposite. So when the both the inputs are 0 0, it generate high output, and when one input is 0 and other input is 1, then it also generate high output. So when one input is high and second is low, that means one input is 1 and another is 0, then it also contain high output, that means it generate 1. And both the inputs are 1 1, when that means when both the inputs are at high, then it generate low output. So it is opposite to the NAND gate. So in AND gate the truth table is 0 0 1, and in NAND gate the truth table is 1 1 1 0. So it generate the opposite output of AND gate. Okay, so NAND gate is basically a opposite of AND gate. Okay, and thus IC 7400 is used for NAND gate. Okay, so now the next and last gate is NOR gate. Next and last gate is NOR gate. So NOR means it is the opposite of OR gate, and IC 7402 is used for a NOR gate operation. IC 7402 is used for NOR operation. So these IC also have a 14 pin. These IC also contain 14 pins. Out of these 14 pins, pin number 14 is VCC and pin number 7 is ground. That means we provide a power supply at pin number 14. So this IC contain 4 OR gate. OR gate 1, OR gate 2, OR gate 3 and OR gate 4. Okay. So now pin number 2 and pin number 3 are the input of first OR gate and pin number 1 is the output of first OR gate. Similarly, pin number 5 and 6 are the input of second OR gate and pin number 4 is the output here. Pin number 8 and 9 are input and pin number 10 is the output. Here pin number 11 and 12 are the inputs and pin number 13 is the output, and pin number 4 is ground. Sorry, pin number 4 is plus VCC and pin number 7 is ground. Okay, now the NOR gate perform opposite operation of OR gate. So this is the truth table of NOR gate. Okay, so when both the A and B are input and Y is output, when both the inputs are 0, the output is 1. When both the inputs are 0, output is 1. Here we saw the truth table of OR gate. So when both the inputs are 0, it generates 0 output. But here when both the inputs are 0, it generate 1 output. Okay, so when one input is 0 and other is 1, then it also generate 0 output. So in OR gate here, when one input is 0 and another is 1, it generate high output. So here NOR gate generate opposite operation to a OR gate. Okay, 1 0. So 1 0 1 plus, oh sorry, 1 0 1 0, it generate 0 output, and 1 1 it also generate 0 output. So this output 1 0 0 0 is exactly opposite to the OR gate, which is 0 1 1 1. Okay, so basically NOR gate perform exactly opposite operation of OR gate. Okay, okay, our last gate is XOR gate. Our last gate is XOR gate, and IC for this gate is 7486. IC for this gate is 7486. So 7486 is also 14 pin IC. So out of this, pin number 14 is plus VCC and pin number 7 is ground. Okay, so here this IC also contain 4 XOR gate. XOR gate 1, XOR gate 2, XOR gate 3 and XOR gate 4. So pin number 1 and 2 are input of XOR gate and pin number 3 is output. 4 and 5 are input, pin number 6 output. 9 and 10 are input, 8 output. 12 and 13 input, 11 output, and pin number 14 VCC and pin number 7 ground. Okay, so now this is the truth table of XOR gate. So A and B are input and Y is output. Okay, when both the input are same, when both the input are same, then it generate low output. It generate low output here. Both the inputs are 0 0, so therefore it generate low output here. Both the inputs are 1 1, that means both inputs are same, so here it generate 0 output. That means when both the inputs are same, XOR gate generate low output, which is 0, and both inputs are different. That when both inputs are different, then it generate high output. That means it generate 1 1. So when one of these input is low or high, that means both inputs are different, it generate high output, and when both input are same, it generate 0 output. Okay, so these are the basic logic gate by using their different ICs. So once again we will see AND gate. The IC for AND gate is 7408. So this number is very important. So you have to remember the each IC number for a particular gate. So for AND gate we use 7408 IC. For OR gate we use 7432 IC. For NOT gate we use 7404 IC. For NAND gate we use 7400. For NOR gate we use 7402, and for XOR gate we use 7486. Okay, now the result of this experiment is all basic logic gates are studied successfully. So our first practical is in. So in next lecture we will see second practical. Okay, now we are stop here.